Hi guys, welcome to Screencast for tomorrow's lesson. Last week we looked at ergogenic aids. This week what we're going to be looking at, and for the next two lessons, is aerobic training. Okay, so when we're talking about the word or the terms aerobic training, we need to consider aerobic capacity. So aerobic capacity is the ability of the body to inspire, transport and utilise oxygen to perform sustained periods of aerobic activity. Now, aerobic training and aerobic capacity is dependent on the efficiency of our respiratory system, cardiovascular system, and our muscular system, something that we've looked at in the past. So when we're talking about aerobic capacity, the sports obviously that are going to have an effect on this, or a component of these sports I'm going to mention, aerobic capacity is vital. So we're looking at long distance events such as running, triathlon, open water swimming, cross country skiing, and so on. Aerobic capacity does contribute to sporting events such as hockey, football, rowing, and so on. But it's the real long distance stuff is what we're interested in. So first of all, like a key component to aerobic capacity is VO2 max. So VO2 max is the maximum volume of oxygen inspired, transported, and utilised per minute during exhaustive exercise, i.e. how much oxygen we breathe in and use per minute during exhaustive exercise. It's measured in millilitres per kilogram per minute. And then the higher percentage attained before fatigue sets in is the higher aerobic capacity of a performer. So obviously elite performers have a higher aerobic capacity than untrained non-elite performers. Average values for untrained performers: male 40 to 50 millilitres per kilogram per minute, and for a female it's 35 to 40 millilitres per kilogram per minute. Now, with regards to this chart here, this graph, sorry, this is just explaining or showing the differences between elite and non-elite athletes and with regards to their aerobic capacity and the sport they take part in. So obviously down here, more your anaerobic based sports, obviously a low percentage of VO2 max in comparison to our more aerobic endurance athletes such as running, marathon, cross-country skiing. Now, in 2012, an 18-year-old Norwegian cyclist reported kind of like the highest VO2 max level, which was 97.5 millilitres per kilogram per min. So he would be right up here. And as you can see, we have obviously things that affect the VO2 max or aerobic training of an individual, and this is what we're going to be going through today. Okay, so first of all, factors affecting our VO2 max. Training, the type of training we do. So training will increase our VO2 max by about 10 to 20%. In aging performers, aerobic training will kind of like maintain or just reduce any decline in VO2 max we get. You'll find out in a minute that one of the factors that affect our VO2 max is age, and I'll discuss that later. So, with regards to training, aerobic training causes long-term adaptations such as increased strength of respiratory muscles, levels of hemoglobin, myoglobin, and mitochondria, and it increases the efficiency to inspire, transport, and utilise oxygen. So as I've just mentioned, age is a factor that affects our VO2 max, and VO2 max declines about 1% per year. Okay, and that's mainly because of lost elasticity in the heart, blood vessels, and lung tissue walls with age. So all of that reduces the efficiency to inspire and transport oxygen around the body. Genetics, or also known as individual physiological makeup. So the greater the efficiency of the respiratory system, cardiovascular system, and muscular system to inspire, transport, and utilise oxygen has an effect on our VO2 max, i.e. the better it is, the higher VO2 max we will have. So strong respiratory muscles and large lung capacities can inspire more air. A large and strong left ventricle will increase stroke volume and cardiac output, raising our blood flow. Increased hemoglobin content of the bloodstream will transport more oxygen for aerobic endurance performance. And then, as we've got here, when we're talking about kind of capillaries, you've got capillarization will increase. This means that we get an increase in surface area for gaseous exchange. And then finally, aerobic performers tend to have a lot more muscle fiber types that are slow twitch. And then you've got the high levels of mitochondria with that. Finally, gender differences. Females tend to have a 15 to 30% lower VO2 max than males from the same group. So females have a higher percentage of body fat, smaller lung volumes, stroke volume, and cardiac output during maximal work, and also lower hemoglobin levels, which obviously reduces the efficiency to inspire and transport oxygen around the body. So they are the factors affecting our VO2 max. You're going to be questioned on these when you come into lesson, so make sure you've got your corner notes done correctly and up to a high standard. What we're looking at now is measuring our VO2 max. So obviously VO2 max is pretty important when it comes to sport, and knowing our VO2 max is very important because it's a baseline data for people. So if you train, you've got a higher VO2 max, you get injured, you stop training, it's really important that the trainer or yourself personally know when you're back up to the level that you were at previously before you actually became injured. So we need to know how we're going to measure our VO2 max. And there's several ways that this can be done, and we're going to just discuss them now. So first of all, lab-based testing or direct gas analysis. Now this is 100% accurate using gas analysis. So you get an objective measurement of VO2 max. So an advantage to this test for testing our VO2 max is you get a direct objective measurement. So it's accurate, valid and reliable. So it's really good. Disadvantages are it's a maximal test to exhaustion and it cannot be used with the elderly. Multi-stage fitness test, you may know it as a bleep test. This is, this gets progressively harder with turns every 20 meters. So advantages of this are you can do it in large groups. So you can do it for a whole team, for example, and it's simple and cheap to set up. The equipment required is not a lot, and this is you'll find this with all of the tests now, apart from obviously that lab-based test, where the advantages to these tests are they're simple and cheap to set up. Direct gas analysis isn't simple to set up; it's specialised equipment. Disadvantages of the multi-stage fitness test is its prediction of VO2 max, not an actual measurement. And then it's a maximal test to exhaustion, so subject motivation might be limited. It's quite difficult to motivate for these type of tests. Queen's College Step Test, just for a point as well, multi-stage fitness test, you can't be used on the elderly either. Queen's College Step Test is a 3-minute step test, and you get a recording of your heart rate at the end of it. Now, this is a sub-maximal test, and it can be used with the elderly. So that's an advantage. It's also simple and cheap to set up. Disadvantage, it's a prediction of VO2 max, not an actual measurement, and heart rate recovery will be affected prior to exercise, such as food and fluid intake. Both of these tests are maximal tests, okay? So they're maximal test to exhaustion, testing our VO2 max, where however, Queen's College Step Test is a sub-maximal test. Finally, Cooper 12-minute run. You run as far as possible in 12 minutes, usually done around a 400-meter athletics track. Advantages, large groups can perform these tests at the same time, and it's simple and cheap to set up. Disadvantages, it's a prediction of VO2 max, not an actual measurement, and the elderly cannot take part in this type of test. So if you get your information and corner notes down for that, we'll just go briefly over it during lesson, and then we can move on to what we're going to do in class tomorrow. So get that down, I'll appreciate it. Thank you, bye.